from the break. I hope you've all enjoyed your first day back at school and you're ready to ease on into some trigonometry. All right, ladies and gentlemen, we're going to start with a little review here. Today in class we talked about some tools for finding missing parts of a right triangle. Well, as you recall, the things that we've learned, we reviewed today, were our friend Pythag. Now, Mr. Theorem gave us a squared plus b squared equals c squared for a right triangle. And then 2, you have your special right triangles, right? Okay, the 45, 45, 90. And the 30, 60, 90 right triangle, okay? Now, both of these are tools to find missing sides. In a right triangle, okay? Now, the only tool to find missing angles is our old friend, the triangle sum theorem, which we all know says the 3 angles in a triangle always have to add up to 180, okay? Okay, right. Well, today I want to take a look at another way that links the sides of an angle, the sides of a triangle, with the angles of that triangle. It's what you kids learned last year as trigonometry. Now, to start off, what is trigonometry? Well, trigonometry is just a set of functions that associates the ratio of 2 sides of a right triangle with either acute angle in the right triangle. Now notice, at this point we can only do sine, cosine, and tangent of the acute angles in the triangle. All right? Now, again, the first, and again, I'm not going to pretend, I won't deny, I'm not going to bury my head and think that you haven't learned about sine, cosine, and tangent in the past, because I know you have, all right? Now, you've talked about sine, cosine, and tangent in triangles. You have not talked about these last 3, secant, cosecant, and cotangent, right? We will talk about sine, cosine, tangent to begin with, and then we will get into the esoterics of secant, cosecant, and cotangent later. Those are just kind of, they're not going to be that useful in the way of finding missing sides or angles, but they do have a role in mathematics. All right, ladies and gentlemen, take a look at this. Here's our relationship that I want to point out. If I have a right triangle, and is there a semi-right triangle? No, that's right. No, that's not. That's right. I don't see a right triangle. I don't see a right triangle at all. I don't have a right angle. Now I have a right triangle, right? Okay, well, I have 2 acute angles. I've got an acute angle down here, A, and then I've got another angle up here. I'm going to call him randomly B, shall we say, right? Well, the definition of the sine of an acute angle is as follows. The definition of the sine of an angle is the length of the opposite leg to the angle. So in this case, it would be this side divided by the hypotenuse. All right? Now, just remembering from today, didn't we say earlier today that in a triangle, if this side is if this is angle A, isn't his opposite side little a? And if this is angle B, and this is adjacent to this side has little b, and if the hypotenuse is here, isn't that little c? All right? So, if my definition of sine, cosine, and tangent are as follows, if sine is the opposite leg, or the leg opposite the angle, divided by the hypotenuse, well, what side, or what leg is opposite that angle A? It's little a. What side is the hypotenuse? Well, it's little c. So we say that, in this case, that the sine of angle A is the opposite leg A over the hypotenuse C. Well, the adjacent, or cosine of angle A, that is the adjacent leg divided by the hypotenuse. Well, what leg is adjacent to angle A? Well, the word adjacent means next to. So if this is my angle, then the angle that's next to it, or the side that's next to this angle, is either this side here or this side here. Now, it can't be this side, and the pure and simple reason why it cannot be is I've already designated this side as a special name the hypotenuse in this picture, right? So that's your hypotenuse. Because of that, the hypotenuse can never be the adjacent side. All right? Only one of the legs can be the adjacent side. So in this picture, the cosine of angle A would be the adjacent leg, which is little b, over the hypotenuse, which is little c. Okay? And lastly, the tangent of angle A. So the tangent of angle A is the side, the opposite leg divided by the adjacent leg. And shouldn't that be little a, which is the opposite of angle A, over little b, which is the adjacent side? Right? So that's the tangent. And so the definition of sine, cosine, and tangent are opposite leg over hypotenuse, adjacent leg over hypotenuse, and opposite leg over adjacent leg. Alrighty. Now, I want you guys to try and do the same thing for the other acute angle in this triangle. Isn't angle B also an acute angle? I want you guys to lickety-split find the sine of angle B, the cosine of angle B, and the tangent of angle B. Alright? I'll give you a second to do that. Okay. Well, in this case, for the sine of angle B, here's angle B up here. So the side opposite him is little b, and the hypotenuse is still little c. So the sine of angle B is little b over little c. The cosine of angle B would be the side adjacent to the angle divided by the hypotenuse. So the side adjacent to B is little a, and again the hypotenuse is little c. And lastly, the tangent of angle of angle B is the side opposite B over the hypotenuse or the adjacent side. So that would be opposite B, little b, over adjacent little a. Okay? Notice that it's real important to use the proper capitalization. We use capital letters for angles, lowercase letters for sides. Now notice that in all 6 of these problems, the words sine, cosine, and tangent, you're only ever allowed to start off by writing them next to whatever angle you're talking about, whether it be angle A or angle B. You always have to start by writing the word sine, cosine, or tangent next to the angle. Okay? Ladies and gentlemen, as a reminder of the definitions, there's SOHCAHTOA. S stands for the sine, O is opposite, H is hypotenuse, C is cosine, is adjacent leg over hypotenuse, and the tangent is the opposite leg over the adjacent leg. If you guys ask nicely, I'll tell you a little bit more about my life as a Ute, and maybe even do a dance for you. So, but again, enough of you have to have watched the screencast and request the dance. Okay? Alrighty then. Now, the next thing I want to take a look at, folks, take a look at, I'm going to use this green, this green sine of B equation. When you take a look at this equation, ladies and gentlemen, this definition has 3 letters in it. Angle B, and side C. Well, wait a minute, isn't that 3 variables, 1, 2, 3, where little b, little c are my sides, and angle B is my angle. Well, if you think about it in the algebraic terms, sine, cosine, and tangent, this allows me to write an equation with 3 variables. If I'm given 2 out of the 3 variables, maybe I'm given this angle here and one of these 2 sides, I know I can find the last variable, right? So again, all the sine, cosine, tangent at this point in your life we're going to do, this is going to be another tool that we can add to solving missing parts of a triangle, right? So, going back to this, I now will have a 4th way of finding missing parts. It's trigonometry, which is SOHCAHTOA. Okay? Now, the nice thing about this, SOHCAHTOA, not only can he be used to find sides, it can also be used to find angles. Okay? Now, moving on. All right, now let's practice again. Before we actually go ahead and start solving for missing sides and angles, let's go ahead and get ready to set up some fractions. All right? Take a look at this example here. It says that I want to find the values of sine of angle B, the cosine of angle B, and the tangent of angle B. Notice, even though I abbreviate the words, I don't abbreviate their words, if you get my drift. I abbreviate the spelling, but I don't abbreviate the pronunciation. I don't say sin of B, right? I mean, sin B, cos B, I mean, never mind. And then tan B, right? We don't say that, All right? We say sine of B, cosine of B, and tangent of B. Right? All right. So if I want to find the sine of angle B, well, let's see here. According to the sine of angle B, I know that the sine of B is the opposite side over the hypotenuse. Well, shouldn't that be just 8 over 12? So I know that the sine of angle B, when I simplify that, is just, well, they both have 4's in them, isn't it just 2/3? So I found the sine of angle B. All right? Notice I'm looking for just the fraction. I'm not actually looking for the missing angle. Now, let's find the cosine of angle B. Well, let's see. The definition of cosine of angle B is the side adjacent to the angle. Well, if this is my angle, isn't this the adjacent side? Well, golly, the problem is I don't know that number. How can I find the cosine of angle B if I don't have the adjacent length? Gosh, is there any way out there? Is there any way that I could find this missing side who's playing peekaboo with me? Ooh, how'd that happen? There she is. There she is. Okay. How can I find this missing side? Well, don't I have 2 sides out of the 3 sides in this right triangle? Couldn't I use Pythagorean Theorem to find this missing side, call it x? Surely I could. Couldn't I say x squared plus 8 squared equals 12 squared? So that would be x squared plus 64 equals 144. So x squared equals 80. So x equals square rooting both sides. I think a little bit of 4 root 5. All right. So this missing length is 4 root 5. All right. So what would the cosine of angle B then be? It would be, well, 4 root 5 over 12. Oh, but wait a minute. These numbers on the outside can simplify, so the cosine of angle B is just square root of 5 over 3. Okay? Then lastly, to find the tangent of angle B, I need the opposite side, which is 8, over the adjacent side, which we just found to be 4 square root of 5. Alright? Oh, that simplifies to tangent of angle B equaling 2 over square root of 5. Oh, but wait a minute. This jerk Kong, he requires that you don't have a radical in the bottom. You got to move it up to the top. And so when I do that, I end up on both top and bottom by the square root of 5. And when I do this, I get the tangent of angle B equals 2 root 5 over 5. So my 3 fractions, the sine of angle B, we found to be 2/3. The cosine of angle B is radical 5 over 3. And the tangent of angle B is 2 root 5 over 5. Okay? And that's how you can use Pythagorean Theorem to find the fractions, sine, cosine, and tangent of an acute angle. Okay, now let's go into how we actually find missing parts of a triangle. Alright? Take a look at this. I want to find sine, cosine, and tangent. Using sine, cosine, and tangent to find missing sides, right? Alright, so take a look at this picture. I'm given a right triangle, but I only know one side. Why can't I use Pythagorean Theorem? Because if I did, I would have 2 different variables, an x and a y in the equation. Pythagorean Theorem, not useful to me. Why don't I use one of the special triangles? Well, my special triangles are 45, 45, 90, and 30, 60, 90. Well, this 42 is neither 30, nor 45, nor 60. It's a funky angle, so I know I can't use special triangles. Well, this is how trigonometry is going to be beneficial to me. To find these missing lengths x and y, I can use trigonometry. Take a look at this. Here's how you do this. Here's the thought process that you got to go through. Well, let's see here. I'm looking for, say, for this side y. Well, I ask myself, what angle am I given? Well, I'm given this 42-degree angle. How does this side y relate to this angle? Isn't this the opposite side? Now, again, I don't want to have another variable in there, so I don't want to use the x side because that would just introduce another variable. Don't I want to use the 15? Isn't he the adjacent side to the 42 degrees? So my thought process is, all right, I'm looking at this angle. I'm looking for the opposite side, and I'm given the adjacent side. Which word, sine, cosine, or tangent, uses the opposite side and the adjacent side? That's right, tangent does. So I can say that tangent of 42 degrees, and again, remember, you would always write the word next to the angle, is equal to the opposite side y over the adjacent side 15. Okay? Now, I failed to say this. Folks are going to need your graphic or scientific calculator at this point. Well, to get y alone, don't you just multiply both sides by 15 on both sides, right here? 15 here and 15 here. So, when you do that, you get 15 times the tangent of 42 is, well, again, you're going to have to do this in your calculator. So, oh, by the way, for those of you with new calculators, make sure, just to be safe, go to the mode and make sure that your calculator is in degrees. Look at mine. Mine, actually, in the fourth line down, radians is highlighted. That's no bueno. No bueno. It's got to be in degrees. So you got to convert that to degrees. Hit enter. Okay. Now go back. And now we just type it in. To get the answer for y, I know y equals 15 times whatever the tangent of 42 is. And guys, I know that you've done this last year, so I'm not going to go through this, a lot. Okay? 15 times the tangent of 42 degrees is 13.508. 506. So y is approximately equal to 13.0. What did I say? 13.51. All right. Not B. 13.51. Okay. Now, to solve for x, again, I have to take a look at the side that I'm looking for, which is x, the side that I'm given with respect to the angle, and the angle itself. Well, again, here's my angle. What side is the 15? That's the adjacent side. What side is the x? That's the hypotenuse. Which word uses hypotenuse and adjacent? Isn't that cosine? Can't I say that the cosine of 42 degrees, and again, there's that word next to the angle, always starting off next to the angle, equals the adjacent side 15 over the hypotenuse x. Now this is a little bit more challenging, because my x is in the denominator. That's no good. You can never have an x in the bottom of a fraction and get an answer. The first thing I need to do is get the x out of there. So couldn't I just cross multiply both sides by x and get x times the cosine of 42 degrees equals 15? Well, again, x isn't alone. To get x alone from here, I have to divide by the cosine of 42. Divide by the cosine of 42. Okay? Now I get x equals 15 divided by whatever the cosine of 42 is. Alright? Again, I'm going to pull out my handy-dandy calculator. Type in 15 divided by the cosine of 42. You get 20.19. So the hypotenuse is, what is it, 20.1? 20.19. 18. So 20.18 units long. Okay? Approximately. Alright? And that's how you find the missing two sides. Alright? You guys try to do this guy on your own. I think you've heard enough of my voice today.